442 and 417. 417 is up because that's there is someone else that does teach that one, but he hasn't the last couple of years. So. No, it's Professor Xyz. Dr. Banks could teach it though. He certainly can.
It's like, who?
I think he mostly teaches grad courses, and then 417. The first time I taught it, it was actually kind of an emergency because Professor Xyz was lined up to teach it, but then he couldn't. And so I was giving it kind of somewhat last minute.
So much for
Yep.
We have an exam, like exam for this class.
We do, yeah. It's going to be the class session right before Thanksgiving.
Okay, so I'm just mostly like.
Yeah, so after this activity, we're going to take a break from ANSYS for a while, and then we're going to, just because I know you guys are working on the projects, and so we're going to cover some theory over the next 3 or 4 weeks, and then the exam will be on that. It'll be mostly on that period, like 95% of it. I might ask like one conceptual question about like meshing or elements, but most of the theory is going to be just from that section. Yeah. There's going to be one homework assignment during that time. And so we do kind of close to when the exams do. So this period of the class is a little bit dicey because you guys have the project. So I don't want to overload you guys too much. And so a lot of stuff will be kind of due after the project.
good birthday books. That's exactly what they said on mine. I got docked because
I wrote.
Dude, that was so
And then he goes, it's Mark here. I'm like, oh, he just left.
I haven't.
It was either they did good or they did bad. One is problems and one is bad.
I guess I'll find out.
It was like literally right before.
Favorite materials or if it's anything in the
Oh, that I have no idea. If I had to guess, probably either Dr. Sue or Dr. Jenkins. That's kind of their going to be offered. That I don't know. It's a lot of the tech electives are kind of put on the schedule a little bit later, just because we have to find staff to teach them. And so a lot of it's going to be based on the availability. So I don't know if Dr. Sue or Dr. James, if they need to teach other classes or, but if it was offered last spring, I'd say it's pretty likely to be offered. Yeah, I'd say it's pretty likely. And so I'd say maybe about like a 90–95% chance. But
you know, like roughly one
usually we figure those things out around Thanksgiving. So a little bit late.
should I just put it like
I would sign up for one that's there now, just in case, and then once we start to those in.
what time?
It would almost certainly be in the afternoon, so 4 o'clock would be the earliest, and then the latest would be like 7 o'clock, somewhere in between.
Like Monday, Wednesday, or Tuesday?
Yeah.
Just like not a Friday.
Yeah, not a Friday.
Okay. Is that a Friday? Like the other class is cool. It's composite. It's a cool class, but it's like I'm gonna show up on Friday at 4.
Oh, that's rough. That's rough. Well, at least there's a lot of parking here on Friday typically.
Yeah, there is.
But then just driving here on a Friday, I haven't had a teacher on a Friday yet, so most of the time I stay home on Friday, so it's nice. And this semester I got it nice because Monday, Wednesday I don't have to come here. So
Yeah, I'm in class Monday. That was like the trade-off.
I see.
They treat it like a government.
So that Avatar the re-release theaters, they already made $10 million in that 1 week. I'm
Crazy.
like, oh my God.
I remember there's so much hype on it. And it's not a bad movie, but it was just impossible for it to live up to all that hype.
I know, just to go away. I'm just like, oh gosh.
They get the fucking dog now. And dude, they're like. Oh, look at this guy.
Milking them.
Yeah, I know. I mean, especially, I remember at the time they were hyping up the special effects, and for the time it was very good. Like, just the hype was just astronomical for like a brand new intellectual property basically. So.
Now it's at Walt Disney World. You can visit the land.
Yeah.
You can't do it here because we don't have enough room to do it here.
Yeah.
You have a dead spider on your 08 Shelby PDF, like when you scan it.
I know. I saw that too.
He just saw, he's like, he was touching his screen.
I do that. I opened up the notes for the first time like earlier this week when I was like, oh man, that's gross. All right, guys. So today is an ANSYS day, and so today's gonna be pretty busy. Actually, I think this one's probably the most involved activity we're gonna do. And so there's quite a few steps. So we're gonna get started right at 5:30. So if you can start up Workbench right now, then we can start right when 5:30 is. What's that?
So like when it comes to like doing a VA on the side part,
Yeah.
there's only exceptions not SDL funds.
STL is one format. I personally like X_T. That preserves a lot more of the information. STL is probably the most basic one, so it works, but I wouldn't recommend it. So I would use either X_T or I would use step STP or IGS. I'd say those are the three I would recommend. Oh yeah.
No, you can't. Forget this. Set X dot X_T.
Yeah,
Okay, and the other
and
one.
then STP or STEP. I just found that pen here, so I don't know if it works. Yeah. STP is the same one with that. There's another one, IG. The SolidWorks file format is patented by SolidWorks, and so they don't let other companies use it.
Oh, okay. Would that be the same with like assemblies?
Yes, assemblies too. So you would convert the assembly to one of those.
Oh, okay. Yeah, because I was having trouble with for like my senior design. Wanted to do FEA, doing a model on SolidWorks. And I was like, oh wait, it doesn't allow it to import geometry, so trying to figure out how to import it.
You have to wait until SolidWorks either buys ANSYS or ANSYS buys SolidWorks. Then it'll work. But I don't see that happening anytime soon.
Okay.
They're both too big.
Okay, thank you.
Yep.
I think it was like 6 overheads. Like I was getting
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Good, dying somewhere in between. Well, as long as you're in between, that's good. Better, yeah, that's true. There's a spider on one of the lecture notes that kind of yeah, he died a knowledgeable death, I'll say that. Okay, so today is our fourth ANSYS activity, and so this is kind of the direct sequel to the or basically the implementation of what we talked about on Tuesday. And so if you remember what we talked about on Tuesday, we talked about two special element types, shells and beams, and so we're going to see how you would actually implement that in ANSYS today. Okay. All right, and so today's actually quite an involved activity, and so I expect to kind of lose people along the way because there's kind of a lot of steps there. So if you're kind of falling behind, don't worry about it. I'll come get you. But I think today will probably be the day outside of maybe the first activity that I'm up here the most, just kind of walking through the steps. Okay. And so with that said, it's a good thing that these lectures are recorded. So if you miss something or if you kind of start falling behind, you can go back and look at the video. But I try my best to explain everything in the PDF here, but sometimes it's a lot easier just to watch someone kind of click through the buttons to kind of show you where it is. Okay. Also, this is going to be our last ANSYS activity for a while, and so I know the project is out there, and so I want to give you guys time to work on that. So this is our last activity, I think, until maybe after the project's due. I need to double check. And so there's this activity. I give you about 2 weeks to work on it, and then the plan is that you'll be working on the project after that full time. Okay. Of course, you can work on the project now. That would help, but after this activity is due, you can work on that. Okay. And so if you haven't started up Workbench yet, I would highly recommend that you do so, just so that we can get started. And besides that, are there any questions I can answer? Yeah.
What was the issue with working on
Yeah, so if you're going to work on these computers, they're a version behind on the one you have on your probably on your laptop. And so you can do a one-way transfer, and so you can go from the computer from lab computers to your laptop because it'll upscale the file formats, but you can't go back. Yeah. Yeah, so you can start the activity here, and then the idea is that you kind of finish it. Yeah. So if you export it, then it'll open up, it'll upscale everything, and then just know that once you start working on it in the 2022, you can't bring it back to 2020. All right, any other questions before we start? Okay. All right, and so just a little bit of intro on the project today. And so like I mentioned, this is the implementation of what we talked about on Tuesday. And so if you kind of scroll down a little bit, here is the geometry that we're going to be working on. And so it's a bridge, okay? And we want to simulate this in ANSYS. The problem is that this bridge has a lot of very thin and slender parts of the geometry. So we have the road here, which is very thin, and then we have the sides of the bridge, which are thin, and we have all of these supporting beams as well, which are very slender. And so if you try to simulate this with solid elements, and so your regular tetrahedrons and hexahedrons, you can do it. I mean, I've seen people do it, but it's not going to be a very good simulation, because of the issue we talked about before. And so you're going to end up with a mesh with most likely a single layer of elements just like this. And that's bad for accuracy. Okay. All right. And so what we're going to do today is we're going to start with this geometry. I'm going to show you how to decompose it, how to take it apart and replace it with shells and beams. And then the majority of the time we're going to spend cleaning up the geometry, making sure it's good in its shell and beam form, and then we'll put it into a FEA simulation. Okay. All right, and so let's go ahead and open up Workbench. And just like we've done before, let's go ahead and start a static structural analysis. So click on static structural, bring it over here. And we're going to import the geometry. So you're going to right click on geometry, go to import, and you're going to import the bridge geometry that I have on Canvas. Okay? And so if you go to the Canvas site, you go to the activity page, there is a CAD file there called bridges.iges. And that's the one that we're going to work with. So go ahead and double click that. That's going to load in the geometry. And then what you're going to do from there is we're going to edit this geometry in SpaceClaim. Okay? And so this is the first time we've used SpaceClaim. So up to this point, we've only used Design Modeler in ANSYS, but SpaceClaim actually makes it a lot easier to do shells and beams. Okay, so that's what we're going to do. And so if you double click on geometry, the default should be SpaceClaim, but if you want to be sure, you can right click it and then click on Edit Geometry in SpaceClaim. Okay. It's going to take maybe a minute or two to start.
Should we join the space claim improvement program or up to
No.
us? No.
Oh, if you want to,
No, then no.
but I'm usually of the opinion of
No.
yeah, these companies own enough of my data. So okay, and so if you open up the geometry in SpaceClaim, you should see this window here. So was everyone able to open up SpaceClaim? Okay. I know it takes a bit of time, so I'll give it maybe a minute or so more. Okay. All right, so here's SpaceClaim. And so, like I said, we've never used this before, but SpaceClaim is you could think of it as like a CAD software. So this is ANSYS's version of SolidWorks. And so you can't do any simulations here. And so the whole point of SpaceClaim is just to kind of work on the geometry. And so you can actually use SpaceClaim to actually create new geometries. And so you can treat it just like a normal CAD software. But I think most commonly what it's used for is to modify geometries to make them better and more suited for FEA. Okay, and we're going to be doing that today. And so we're going to be modifying this geometry to make it so that we get shells and beams instead of all of these solid elements. Okay. All right, and so whenever you open up SpaceClaim to modify an existing CAD geometry, it's always good to try to repair the geometry. Okay, and so you're going to go up to the top ribbon here. You're going to click on Repair, and then you're going to click on this entry here called Stitch. And so I don't think this geometry has any issues with it. And so if you click on Stitch, you should see on the bottom here, it should say no areas found. Okay. But I want to show you this, and so that if you do plan on using SpaceClaim for your projects, either the midterm project or the final project, this is usually a good thing to do, just to kind of make sure if there's any kind of very obvious issues that SpaceClaim can take care of. Okay. And so if there were some issues to take care of, what you will see is that this green check mark will become highlighted. And so that basically tells you that ANSYS or SpaceClaim has found some issues, and then it can fix them right away. Okay. But in this case, we don't have any, and so it's okay. And then we're going to do the same thing with gaps. Okay. And so if you click on gaps, you can see that there's one area here. And so that right there counts as a gap that SpaceClaim is saying is going to cause an issue. And so if you click on this, normally it will fix those areas, but that thing right there is actually something a little bit special that we'll actually deal with later. So it's not actually going to fix it, but I did want to show you what it would look like if it did find an issue. Okay. And so for now, don't worry about it. It's SpaceClaim's not going to actually fix that. But I just wanted to show you, where you would find it and what it would look like. Okay. And so now that we've done kind of a very basic kind of stitching and very basic repair on the solid, we're now ready to start modifying it for our simulation. Okay. Okay. And so the first thing we're going to do is we're going to look at all of the thin surfaces and then turn them into shells. Okay. Right, so remember, a shell is basically a 2D surface or a 2D representation of a 3D surface that's very thin. Okay, and so we actually have three bodies in this assembly here that can be suitable for shells. Okay, and so we have the road, and so you can see the road itself is very, very thin. Okay, if you zoom in on it, you can see it actually does have some thickness right now. Okay, and so it is actually a rectangular slab, but it's so thin that it's going to be much more suited as a shell. And actually the sides of the bridge as well. And so the sides of the bridge are also very thin, because if you look at this dimension, you can see that it's much thinner than the other two dimensions. Okay? And so to make a shell element, you're going to click on Prepare. Okay? So Prepare is on the top ribbon to the right of Repair. Okay? And then you're going to click on this operation here called Mid Surface. Okay? And so if you remember when we talked on Tuesday, a mid surface basically takes two parallel surfaces, eliminates them, and puts a shell right in between. And so you're going to click on mid surface, and then you're going to click on two parallel surfaces here. Okay. And so let's start with the road, because that's the simplest one to do. And so with making sure that mid surface is highlighted here, you're going to click the top of the road. And so that's going to highlight one surface, and then you're going to rotate around. You can use the middle click button to rotate the geometry. And then you're going to click on the bottom surface of the road. Okay. And if you did everything correctly, the first surface you click should highlight blue, and the second surface should highlight green. And so to complete the mid surface operation, you're going to click on this green check mark here for complete. Okay. And so after you do that, and you kind of move around a little bit, you click, you'll see that the road has been replaced by a very, very thin sheet. And they even made it translucent for you to kind of see that it's very thin. Okay. If it's not translucent, then don't worry. This might be a 2021 thing, but it is, as long as you can see that it's very thin, then you were successful. Okay. I think mine does translucent by default, but they might have changed that in a later version. Yeah. I mean, they update the software every year. It's like you have to buy. It's like buying a new version of a textbook every year. They just kind of move a couple words around, and then they make you pay $120 for it. All right, was everyone able to create a mid surface for the road? Okay. If it's translucent, that's great. If it's not, then don't worry about it. Okay, and so we're going to repeat the same thing. And so mid-surface should still be highlighted. And you're going to do it for the sides of the bridge. Okay, and so you're going to click on, let's say the inner surface for the bridge, and then you're going to click on the outer surface. Okay, and so you'll see the same thing. It's going to highlight green and blue. Okay, and you're going to click on the check mark, and then you click elsewhere, and then it's going to replace it with the shell. Okay. And then we're going to do the same thing on the other side. And so the other side, we're going to click. It doesn't matter which one you click first, as long as you click both parallel surfaces. Okay. And then once you click both parallel surfaces, you're going to click on the green check mark again to finalize it. Okay. And so once you're done, you should see the road and both sides, both the left and the right side of the bridge should be replaced with shells. Okay. So they should be very, very thin at this point. Okay, everyone, was everyone able to mid-surface? Yeah. So you're going to go to prepare and then mid-surface right here. Yeah. So it's like a sandwich. Yeah, it's like a sandwich. Exactly. Yeah. Okay. Yeah, so you want to make 3 shells. And so you want to make a shell of the road and you want to make a shell of the left and right sides of the bridge. All right, was everyone able to do that? Anyone still need a bit more time? Okay. All right. So I'm going to move a little bit quickly just because there's a lot to go through, but then I'll come back around, at different points. Okay, so the next thing we're going to do is we need to extract out the beams. Okay, and so all the other surfaces remaining, or all the other solids remaining here are slender, and so we want to transform them into beams. And so you're going to go still in the prepare tab, and so make sure you're clicking on prepare, and then you're going to click on this this entry right here called extract. Okay, and so if you read the tooltip for this, you can see that it extracts a beam from a solid, and so the solid must have a constant cross section. But this part's really easy. And so all you have to do is, so if you make sure that extract is highlighted, you're going to mouse over to a beam part. Okay, and so it should highlight. And so after you highlight it, just click on it. And once you click on it, it's going to replace it with a line. And so that line there is going to be your beam element. Okay? And you're going to do that for all of the beams on the bottom as well. And so in the end, we were actually able to transform every part of this geometry into shells and beams, which is going to be great. Okay. Because it's translucent, it's hard to rotate. Yeah, okay, that's fine. All right, and so after you extract all the beams and you've mid-surfaced all the shells, you should be left with something like this. Okay. And then the fun part begins. And so this is when this is usually when I start to lose people. This next part is a little bit complex. All right, any questions on this so far? Okay, all right, and so now that we've converted everything to shells and beams, you would think that this is good right here, but it's not. And so we are going to have to clean up this geometry. And so creating a mid-surface and creating beam is not a perfect process because we do lose some geometric thickness. And so just to kind of highlight this, let's look at how this beam here connects to the side of the bridge. Okay. It's a little bit hard to see, and so I'm basically zooming in here, right? And so if you zoom in on this part of the bridge right here, you can see that this beam is no longer connected, right? And so in the original geometry, that part was connected because the bridge actually had some thickness. But since we got rid of that, now this beam is not connected. Okay, so now we have basically a beam that's floating in space. And so what we need to do is we need to clean up this geometry so that we can actually use it for FEA, because right now, this beam is floating and we won't be able to do anything. Okay, And so the tool that we're going to use is one called extend right here. Okay. And so if you read the tooltip for extend, what this is going to do is that it's going to extend any surfaces or edges that are not connected to something, and it's going to extend them until it is connected to something. All right, so we're going to click on extend. Okay. And then you're going to see that it's going to say that no areas are found. Okay. And the reason for that is that if you go over to this side of the interface here, you'll see that it's only looking for areas that are within 10 millimeters of each other, okay? Which is really small. And so for this particular geometry here, we need to increase this range. And so we basically need to tell it to look for any surfaces that are at least 50 millimeters apart, okay? And so you're going to change that maximum distance to 50. You're going to hit enter. And then you're going to click, after you hit enter, you're going to click on extend again. And then from here, it's going to show you that it found 8 areas. Okay? And so in other words, it found 8 beams that are not connected to anything that can be connected to something if we extend it. Okay. All right. And so if you look at the figure here, if you look at your geometry, it's going to highlight everywhere that it can extend with kind of a red circle. Okay. And so for now, you should see that the top beam can be extended, as well as 3 of the bottom beams can be extended as well. All right, so to finalize the extension operation, you're going to click on complete. Okay, and you may have to click it more than once. And so after you click on that, and you kind of zoom back in on the top part of the bridge, you'll see now that the beam is connected to the bridge as it was before. So that's what we want, because after this, when we move this into ANSYS, this is going to come in as an assembly. And so we need to make sure that all the parts that should be touching are touching, so that we can form a connection at those points. Okay. All right, any questions on this part here?
What about the other beams?
Right, so we're gonna take care of the other beams in a bit, but there's another issue with the other beams. This geometry, I chose this one on purpose because it is a little bit messy, and so, but that's good, because then it's going to give us practice on what we need to do to clean up geometries like this. All right, question? Yeah. So the question is it an issue if there are only 4 to 6 areas where the extend operation was applied? Yes. And so that's on purpose. And so, you should still have a few beams here that aren't connected yet. And we're going to fix those next. Yeah. Okay. All right. And so just as everyone, just as a few people have noticed already, there are still some beams that aren't connected. Okay. And let me show you why. And so, the way the extend operation works is that it basically takes these beams and tries to extend them in their longitudinal direction. And so in whatever direction the beam is going, it tries to see if it can just extend it there until it hits something. Okay. But if the beam is positioned in a way where if you just simply increase its length, but it doesn't hit anything, then the extend is going to fail. Okay. And so let me show you an example here. And let me actually get rid of the road here as well, just so you can see. I guess this one. Okay. And so if you want to hide a surface, you can uncheck it here on the left side. And in fact, because we're not going to be working with the road just yet, you can go ahead and hide it. Okay. All right. So now we just have the bridge and all of the supporting beams. Okay. And so if you look and kind of highlight over it, you'll see that there's still some beams here that aren't connected, right? And so this beam right here is one example. And so this beam right here, the extend operation failed. But let me show you why that is. Okay. Let's do this. Okay, and so if you look right on at the beam, and you kind of zoom in really closely. Okay. It's a little bit hard to see, but this little dot right here, let me use red. This little dot right here is the beam. Okay. And so you can see here that it's actually physically below the bridge. Okay. And so when we extracted this beam, the beam was actually a little bit offset down. And so because of that, when we extracted it, it put the line a little bit too far down such that it's not connected to the bridge. And so when we try to extend this, what Space Claim was trying to do is that it was trying to extend this until it hit something, but it never hit anything. And so it said that, okay, we don't need to extend this beam. Okay. And so that's an issue. And so we're gonna have to fix this. And so what we're basically going to do is we're going to move this beam. Okay, we're going to move it upwards until it intersects with the bridge. Okay, and that's true for these ones as well. Okay, all right. And so to move a part of the geometry, we can do that here in Space Claim because remember this is basically a CAD software. And so to move a part of the geometry, you're going to go to Design, and you're going to go to Move. Okay. And then you're going to click on the beam and you can move it upwards, but don't do it yet, okay? Because we don't know how much we need to move it up, right? And so we first need to measure how much we're going to move it up, okay? Okay. And so actually our first stop here is going to be on the measure tab. Okay? So you want to come to the top and go to the measure, this measure button right here. And then you're going to click on this tool right here called measure. So it looks like calipers. Which is an appropriate symbol for it. So you're going to click on measure. Okay. One thing you're going to need to do after you click measure is you're going to need to click on this checkbox right here for show XYZ vectors. Okay, because what we want to do is we want to show basically the Y displacement of this bridge. Okay. And so now is the tricky part. And so basically we want to find out how far below, or in other words, what's the Y distance between this bridge beam and the bridge itself, okay? And so you're going to hold Control on your keyboard so you can select multiple entries at once. You're going to click on the beam, and then you're going to click on the bottom edge of the bridge, okay? So let me kind of highlight it here. And so if you click on both the bottom of the beam and the beam and the bottom of the bridge, you should see kind of the measurement tool come up. And for this particular beam, it's about 1.9 millimeters off from where it needs to be. Okay. And so we're going to move this beam upwards 1.9, at least 1.93 millimeters now. Okay. And so if you click on a different beam than me, all the beams are off by a different amount. And so if you click on a different one than me, you might have a different measurement. But just kind of keep in mind what that measurement is. And then, that's what we're going to move it up by. Okay. And so if you have a piece of paper or if you have a notepad, let me open up a notepad here actually. Just so you remember it. I have to do this because I'm getting old and forgetful. And so I'm going to write down what the measurement is. And so I'm going to write down minus 1.9221 millimeters. Okay. Or if you have better memory, you can just remember it. Okay. All right. And then after that, you're going to go to the move tab right here. And you're going to move that beam. Okay. And so you're going to click on move. You're going to click on the beam. Okay, and then after you click on the beam, then this kind of XYZ thing is going to show up. And so what you're going to do is you're going to click on the arrow in the direction of where you want to move it. And so in this direction, in this case, we want to move it upwards. And so I'm going to click on this blue arrow. Okay, and after you click and drag it, you'll see that you can click and drag it as much as you want, but we only want to move it up just enough that it's going to intersect with the bridge. Okay, so I'm going to move it up, and then in this box entry right here, I'm going to write 1.923. Okay. And so that's going to move the beam in the perfect position for where now it's going to be intersecting with the bridge. Okay.
Position is set up right now. 1.5. Is that 3 still stored there as well, or is it?
Yes.
Just
So I put it up a little bit too much on purpose just to make sure that we get some intersection. And so you could have done 1.93. You could have done 1. Oh, I see what you mean. Yeah, the 3 there is still safe. Yeah. Okay. All right, one more. I'll do one more step, and then I'll go around and kind of help people because I know this step is a little bit difficult. And so once you move the beam up to check to make sure that it actually worked, you're going to go back to the prepare tab, and then you're going to click on extend. Okay. And then if you move the beam up properly, you should see that it should identify 2 extra areas now, and you can go ahead and extend the beam so that those ones meet the bridge. Okay. Okay. And so what I want you to do is I want you to repeat that step for the last 3 remaining beams. And so you should have to do this for 4 beams in total. And so you're going to have to go measure. So every beam is off by a little bit more, by a different amount each one. So you have to measure each one. You're going to have to move each one individually and then extend them until they reach the bridge. Okay. And so I'll give you guys maybe about 10 minutes, 10, 15 minutes to do that. I'm going to walk around and help people. And so if you're having issues, I'll come around and then we'll do the next step once I come back. Okay.
All around too.
They're not all, some are like 0.4. Whatever it was,
What about one? Oh, yours is down there, so I'm sure you're close.
First, let me. So I think that's it. So it's. Stop right here. So right now we're space
Control.
It's not to.
We want, we actually want to. So when you put,
Oh.
each beam is different. Yeah, oh, that one was one on the that one's one. That's the minimum. Yes, well, the ones that aren't, so there's some, exactly. It doesn't have to be. You want to be as close. Yeah.
Listen, they're spying on you. I'm joking. Okay, okay. Oh, okay, okay. I said it to him, I was like,
Okay. I appreciate it. It's just, yeah. Yeah, so
That sounds like that's.
that's why. Yeah, measure each one. That's what I'm saying. Yeah, so when you move into How you guys doing on Zoom? Let me go ahead and I'm gonna catch up really quick. Kind of watching this at home. So this is for the video, and so for the recording, I'm sure people are gonna be looking at this again. I'm gonna be doing this. One thing I've been seeing is that when you move, you want to make sure you click on the entire beam. Don't click on just the points, because then you're not going to move the beam. You're just going to move the points. It's good. Measure. Click. It's minus 1.9.
Yes.
Okay. All right, how's everyone doing? Was anyone able to complete all the extents? Okay, let me go. I'll do one more. And so if you want some reference, these are all the measurements I got from starting from one end of the bridge to the other. Those are all the moves that I did. So I did 1.93, 1.48, 1.9, and then 0.42.
I just realized the one side has a longer structure than the other.
Yeah, that happened to him too.
I was like, what? Why everything looks wrong? It's not like it's not. It's like angles, isn't it? It's not like right angles, but it's actually there's like freaking out.
No kids. No kids at this. I usually go first. This is my first time there.
How I do my is. Know that I go on sides.
Now it's
Yeah.
like if I'm this fight, there's they have multiple salaries. This is our smart way.
Yeah.
You just open a bar.
Yeah.
See, they look at her. This shop right here.
And so after you get back over here, you do 129. Now we can try to speed 129 is like the vertical.
I don't know. This is repeat that word.
Yeah. You can. First, I just want to make sure that you're not moving. No, I don't. I do it by point. So you want to. All right. So let's move on. And so believe it or not, I'd say we're still only about maybe 60% done with the activity. So we need to kind of move on. So if you got it to extend, that's great. If not, I'm going to try to save some time at the end to kind of come back and help you out. But I want to kind of make sure we get as many people to the end as much as possible. Okay? All right, so we're almost done here. And so the last thing we're going to need to do is we're going to need to work on the road. Okay. And so if you bring back the road, and so if you hit it to bring it back, you're just going to click on the check mark next to solid 3. Okay. And so that's going to bring the road back. And so we're going to do the same thing for the road. And so if you kind of zoom in on the road here, you can kind of see it's not connected to the bridge, and it's actually not connected to the beams either. Okay, so we need to move the road downwards until it's connected to those three. And so we're going to do the exact same procedure that we did for the beams. So we're going to click on measure first. Yeah.
All the beams are at the same level. I guess they all are now. Never mind.
They just have to be close enough. And so yeah, they have to be extended and just close enough. And so you're right. If you kind of measure each of them exactly, they're probably offset by a little bit, but that's okay. They're all connected and they're all close enough. Okay, so we're going to click on measure here. We're going to click on the road. And we're going to click on the bottom edge of the bridge, okay, because we want to move it downwards. And you can see here that the amount that we need to move it down is around 28.3735. Okay. But here you have to be a little bit careful. And so I know what I've been telling some of you is that for the beams, we kind of overshot it a little bit to try to make sure that it intersects. Here we want to make sure we don't overshoot it, because if we move the road down too much, it's not actually going to intersect with the bridge. Okay, so we're actually going to stop this one just a little bit short. And so I'm going to move this one down 28.37. Okay. And so when you're moving pieces of your geometry around, with shells and beams, you have to kind of think about, how much do I need to move it down? Should I overshoot it or undershoot it? Okay. And so this is a case where we want to undershoot it because we don't want to move past the bottom of the bridge. Okay. And so for this one, you can kind of copy my value because there's only one road. And so the amount that I'm going to move it down is around 28.37. Okay. Yeah. It could. So I think what I was seeing too is that when people were moving the beams around, you might have moved the bridge up a little bit and moved it down. But that's okay. And so there's going to be some variations kind of based on that. But the most important thing is that everything is going to be connected and everything's going to be attached.
You don't have to hit negative numbers at all, right? If you move it down, it's still at the distance as possible.
Exactly. Right. Yeah. And so I'm going to go down. I'm going to click on design. I'm going to go to move. Okay. And so I'm going to click on the road. And so the road, once you click on the road, you're going to click on the blue arrow again. You're going to move it down. And I'm going to move it down 28.37. Okay. Or however much you need to move it down to intersect. Okay. And so you can see after I did that, the road is now sitting right on top of the beams. And so if we do just one more extend operation. Okay. And so if you click on extend after you move the road down, you'll see that there are two more areas that you found. And those two areas are the left and right sides of the road. And you're going to click on the green check mark. Okay. And so after you fix that area, then your bridge should look like this. And so, you know, we changed this geometry, we replaced it with shells and beams, and then we cleaned up the geometry to make sure everything is connecting the way it needed to. Okay. Because the issue that you run into when you use shells and beams is that you actually do get rid of parts of the geometry. And so most of the time, you're going to have to use things like this to clean it up, to make sure everything is connected the way it's supposed to. Okay. All right, any questions on this? All right, and so that's it for space claim. And so you know, I'm going to go ahead and exit out of this for now. If you're still working on, you know, the extensions and the moving and stuff, you know, don't worry about it. I'll come around again later. But now we're going to move over to mechanical. Okay. And so if you were able to extend the road, you are good to go. So you can close space claim. And then you're going to double click on model here to open up ANSYS mechanical.
It auto saves, right?
Yeah, it auto saves. I mean, the geometry auto saves, but then if you close Workbench, then that does not save. Thanks. Okay, and so once you're in mechanical, you should see your geometry again. Okay. First thing we're going to do, you know, we actually still need to do quite a lot before we run the simulation. Okay. But the first thing we're going to do is we're going to get rid of this extra surface right here. Okay, so it's this kind of little chopstick that's kind of sitting by itself up here. And so if you go to your geometry list in mechanical, you should see that there's one surface called sys/surface. And so we're just going to go ahead and suppress that. Okay, so we're going to right click on that, and then we're going to suppress the body. And what that's going to do is that it's just going to get rid of it from the model. Okay. I actually don't know what that is. It's just kind of an artifact of the CAD model, but you know, it's not something that we need for the simulation. Okay. All right, and so the next place we're going to go here is actually on connections. Okay. And so if you remember from our flagpole or our signpost activity, right? Whenever you have an assembly of parts in ANSYS, you need to define how those parts are going to interact. Okay? Because once the simulation begins, you know, those parts are going to either, you know, stick together or they're not going to stick together, depending on how you define it. We actually have quite a complex assembly here. So each individual shell that we made and each individual beam is actually a separate part here. Okay, and so you can kind of click and highlight all of these. And so we need to define how all these parts are going to interact. Okay. And we're going to do that through connections. Okay. And so what you'll notice at first is that the connections are empty. And so when you make shells and beams, then by default, the connections are not going to be populated. And so that's different from our activity 3. Because remember from activity 3, you know, ANSYS kind of populated that for us. And so we need to make these manually. So you're going to right click on connections. You're going to insert. Okay. And then what you want to do is you want to click on manual contact region. Okay. What that's going to do is that it's going to allow you to define different parts of your model that have to be, you know, physically connected. Okay. Okay. And so after you click on manual contact region, then a new area here is going to show up. And what it's asking you to do is that it's asking you to define the two parts of the geometry that are supposed to be connected. Okay. Okay, so let's do something simple first. So let's connect the side of the road to the bridge. Okay. Okay, so first thing we're going to do is you're going to click on, make sure you click on edge selecting mode here. Okay. Because what we want to do is we're going to click on the edge, one edge of the road. Okay. And so it's a little bit hard to do, but you know, if you look on one side of the bridge, the road is kind of hanging over. And so we're going to zoom in on that edge. We're going to click on that edge. Okay. And so that edge should highlight green, just like that. Okay. And then once you've selected that edge, we need to assign it to one of these entries here. Okay. So there's one entry called the contact, and the other entry called the target. And so for this edge of the road, we're going to assign it to the contact region. Okay. And so after you select that edge, you're going to click on contact, and then you're going to click on apply. Okay. And then what that's going to be connected to is the side of the bridge. Okay. And so the side of the bridge is a surface, and so you're going to switch to face selecting mode up here. Okay. And you're going to switch to after you switch to face selecting mode, you're going to click on the side of the bridge. Okay. Make sure that that surface right there is highlighted, and then you're going to select that as the target. Okay. Okay, and so after you see that, you can see we've created a new connection here, and it's a connection between the this side of the bridge and the road, and that's now a bonded connection. Okay. Okay, and so we're basically going to be doing this for all the different connections that we need. But I'll go through that with you guys in a bit. But are there any questions on this connection here? Yeah.
So how are we supposed to make the road to the side of the road?
Yeah, so we're going to do each one individually, and so we're going to make multiple kind of contact regions with this.
Yeah. So we're just gonna have to keep a manual contact region.
Yeah, but you can bond multiple things at once. And so let me show you an example. And so the next thing we're going to connect is we're going to connect the ends of the beams to the bridge. Okay, and there are 8 beams in total. And so we're going to right click on contact here. We're going to click on manual contact region. Okay, and we're going to connect the ends of these beams to the bridge. Okay, so the first thing we're going to do is we need to select all the ends of the beams, and we're going to click on point selecting mode or vertex selecting. Okay, and what you're going to do, and you might have to zoom in for this, is you're going to click on each end of the beam right here. Okay, and you're going to make sure you select all of them. And so you might have to, you're going to have to hold Control. You might have to zoom in to different parts of the surface. Okay, so that's one. That's another one. There's one right there. There's one right there. And there's one right there. Okay. Okay. And so you can kind of group select all the points on for the beams on one side. Okay. And so there should be 8 of them in total. And once again, we're going to choose these as the contact. And so after you select the 8 points that are on the edges of the beam, okay, we're going to assign that to be the contact. And then the target here, we're going to select to be the side of the bridge. Okay, so we're going to switch back to face selecting mode. We're going to click on the side of the bridge and click apply for the target. Okay.
Only one side at a time.
Yeah, one side at a time. Yeah. And then you're going to repeat that for the other side. So let me kind of rename these.
One to be contact.
Yeah.
Does it matter if we do inside base or the outside base?
Wait a second. No, it's a shell, so it's the same. DJ, what was your question?
How many points do we need on the bottom?
There's 7 on the bottom and 1 up top. Okay. And so I know this part's going to take this is another part that's going to take a bit of time. And so I'm going to go around again, but let me list out all the contact regions that you need. Okay, and so you need 1 left side road to bridge. 2 left sides of beams, 8 of them, to bridge. Okay. You're gonna need the same thing on the right, so right side of road. Bridge. 4 right sides of beams, 8 of them, to the bridge. And then 5 is gonna be the road surface to bottom beams. And there are 7. Okay, and so you should, you should have 5 contact regions that you're going to define, and these are the list of those. Okay, and so I'm going to go around and help people. I'm going to prioritize the ones that are still in space claim, and then if you're on the contact parts, then I would say try to work with the people around you. But I want to make sure everyone gets past the space claim part.
One side of the road is lower than.
That's what I figured, right? I try to count for that, but.
Still. Looks like it's the left side of the road. Once you measure, that's. Yes. We want to move. So that kind of. Yeah. Click on compare. Click on the green check.
Couldn't be when I started.
This activity is cool. Alright, so. Just a lot of places. Right. Is this the same one that you mentioned that you were off by? Oh, okay. Oh, okay.
Yeah, that's what I'm saying.
So it's the road surface, the target.
I did left first. Then I did the right side. I did both. I get the difference. Just to show us.
Oh, okay. Somebody said, it wasn't. That's weird. You shouldn't do that. Now, you should be good to that. One is, it's still the okay. Yeah, I think one side could be that.
As long as you're both private, it's really hard. It's not, as long as everything. The reason is that. Not so powerful. Oh, you're right, you might get one.
Could be that. Yeah, I think it's just I don't know why. Down
That was not the dog, that was the ultra. That was the ultra, it was like a little ultra thing to collect together. It's a ultra. I think it was just typical. They have like a perfect. And then on the third one, that's when they.
As long as everything. What actually?
It's a tiny one. No, what is it? I lost my flash drive.
Oh. Normally.
Not this last. Yeah. It's probably 150, your fans are about 6 degrees. It is touching in the time. Like, so what I think I do like complete opposite. It's crazy. Oh, dude, yours are.
Yeah, so.
And a little bit of space.
Yeah, that's. You gotta try that. Yeah. Yes.
It's like the specific, like. Only happens.
That's okay. So what else one is.
I had my laser when I went to my. It's a new purchase for me.
We wrap it up now. All right, so we're very quickly approaching the end, and so question: road to beams is going to be an edge section. Yes, yeah. So one thing I didn't really get to say. So when you're making the contacts here, it does actually matter which one you set as the contact and which one is the target. And so the target should always be the bigger, whichever one is bigger of the surfaces. And so you know, if you made a connection between, and then there's still a question mark here, try swapping them. And so if you are getting a question mark here, you can right click and click on flip target and contact, and that's going to swap them for you. And so you want to swap it so that the target is the bigger one between the two. Okay, and so you know this always happens every year. So I didn't really get to the end of this activity, and so you know, and so all the instructions are there in the PDF, and so you can try to kind of finish it from there. Of course, this video will be uploaded online, but kind of the most important thing to get through today is if you can get through the connections, then that's all of the new stuff. And so after that, it's just a regular mesh. You're going to apply boundary conditions on it. So all of that's the same as before. But you know, if you were able to get through all the contacts today, then you're in really good shape. Okay. If you're still working on it, that's fine. I'll stick around as long as I can until Professor Gary comes and picks me out. But you know, you're always welcome to come to office hours too. Okay. All right. So thank you everyone for coming today. I know today was you know, today was a rough one. This activity, I think, is always the roughest activity. And so, you know, thank you guys for your patience and thank you guys for sitting in. And so have a great weekend, everyone. I'll see you guys next week.
Help.
You should have 5.
So how you manually extend?
Yeah. I don't know why some people are.
That's I measured. So
Okay. So weird. It's 50 millimeters. Let me try this first. Let me try something else first.
It might be like, doesn't like it to be right on the edge, maybe it's, yeah, see now I can do it.
Okay, I think what happened was that when you were moving one of the beams, I think you moved the bridge up a bit too, because I think they are off a little bit, but you can see this one is much lower than this one. So I think this bridge was kind of, the side of the bridge was kind of chopped. That's okay. So the important thing is that all the everything's making contact as it is. Don't worry too much about the geometry, so that's not going to make too many difference.
I cut it off.
I think what happens, so when you click move, you have kind of multiple things selected and you move it up. It's going to move all the things that you selected.
No, I meant like, why is this, like, what's the difference between this and this?
I think what happened was that when you measured this side of the bridge and the beams, and then you had both selected, and then when you went to move, you still had both selected, and when you moved the beam up, it also moved this side of the bridge up.
I wasn't the only one. There was another guy too. Yeah, that's
Yeah.
So
I think something like that.
okay, maybe I should just redo the whole thing again.
If you want, I mean, the important thing is that everything is connected, and so that's kind of important for that.
Okay.
And so I'm not, I mean, for the activities, I'm not checking them much in general.
Yeah.
For this one in particular, it's the more important thing is that you get the context, not so much the geometry. Because that little edge on the bottom is not going to make that big of a difference for the stresses and stuff like that.
I wonder if it is right at the edge and just won't extend, then do I just lift it up, extend it, and put it back down? Is that one way to do it? Yeah, I think I'll do it that way for now on.
Okay.
Thanks.
Thanks, guys.